You've probably seen one before. It's a simple little plastic stick that can change a person's life in a matter of minutes. But have you ever actually stopped to wonder what is going on inside of it? Well, today we're going to break it down and uncover the incredible science hiding in plain sight in a home pregnancy test.
To really get how the modern test works, we need to go back in time. And I mean way, way back. Picture this. It's 1350 BC. You're in ancient Egypt. There are no chemistry labs, no little plastic sticks, just pyramids and papyrus. So how on earth would you figure out if you were pregnant? The answer, as you might guess, is pretty wild.
You heard that correctly. The very first recorded pregnancy test involved, urinating on a bag of wheat and barley seeds. The idea was if the seeds started to sprout, that was your positive result. They even thought they could tell the baby's sex. If the wheat grew, it was a girl, and if the barley took off, it was a boy.
Now, I know what you're thinking. This has to be just some old folklore, right? Just a superstition. But get this. Fast forward over 3,000 years to 1963, scientists decided to actually put this ancient method to the test to see if there was anything to it.
And believe it or not, the results were kind of shocking. The ancient seed test was actually 70% accurate. Not bad, right? The theory is that the higher levels of estrogen in a pregnant woman's urine could help the seeds grow. Of course, 70% is nothing compared to the more than 99% accuracy we have today. So, what changed? What's the secret ingredient?
Well, the big leap forward wasn't about estrogen. It was about discovering a totally different chemical messenger. This one hormone is the key to basically every single home pregnancy test you can buy today.
And here it is. Meet HCG, which stands for human chorionic gonadotropin. It's a special hormone that the body really only starts producing in the very early stages of pregnancy. So those over-the-counter tests, they're really just tiny, super specialized HCG detectors.
So what does HCG actually do in the body? Well, you can think of it like it's kicking off a biological game of telephone. It sends out that very first crucial message to the body that says, hey, hold on, don't shed the uterine lining, which of course creates a safe and stable home for the embryo. All right, now for the really cool part. Let's follow the journey that a drop of urine takes as it travels up that little absorbent strip inside the test. It's like a tiny 3-stage obstacle course, and it's all designed with some seriously incredible precision.
Okay, so the liquid moves through 3 very distinct zones, and each one has a very specific job to do. First up, you've got the reaction zone, then it moves to the test zone, and finally it ends up at the control zone.
Okay, so in zone 1, the reaction zone, this is where the urine first meets these microscopic little helpers called antibodies. Now, these antibodies are free-floating, and they're specifically designed to latch onto any HCG that happens to be passing by. And here's the clever bit. They're also carrying a tiny enzyme that can activate a dye. Think of them as HCG-seeking missiles armed with a little payload of paint.
This whole setup is based on a brilliant scientific method called a sandwich assay. And the goal is exactly what it sounds like: to trap, or sandwich, the HCG hormone between 2 different antibodies. When that sandwich is complete, that's what triggers the visible signal, the line we're all waiting to see.
So now we're moving into zone 2, the test zone. This area is coated with a second group of antibodies, but these guys are fixed in place. They can't move. As the HCG, which is already carrying that first antibody, flows past, this second antibody grabs onto it, completing the sandwich. This locks everything into one spot, allowing that little enzyme to activate the dye, and poof, there's your first visible line.
And finally, the liquid reaches zone 3, the control zone. This is basically quality control. Any of those leftover mobile antibodies from zone 1, the ones that didn't find any HCG to grab, just keep flowing until they get trapped here by a third type of antibody. They activate their dye, and that forms the second line. That's the line that tells you, yep, the test is working just like it's supposed to. If you don't see that control line, you know you've got a faulty test.
So these tests are pretty brilliant, right? But they are not 100% foolproof. Sometimes they can get it wrong. So let's quickly break down what it means when you hear about a false positive or a false negative result.
It's pretty much exactly what it sounds like. A false negative is when the test says you're not pregnant, but you really are. And a false positive is, you guessed it, the opposite. The test says you are pregnant, but you're not.
So why do these mistakes even happen? Well, false negatives are usually the most common error, and they often happen if you just test too early before your HCG levels are high enough to be detected, or maybe if your urine sample is too diluted.
False positives are way more rare, but they can be caused by things like fertility treatments that use HCG injections, or certain medical conditions, and even some rare types of cancers.
And that last point leads to a truly mind-blowing fact. Because some types of testicular cancer also produce the HCG hormone, it is actually scientifically possible for one of these home pregnancy tests to tell a man he's pregnant. It's a bizarre but very real example of how this hormone can show up for totally different reasons.
You know, when you take a step back and really look at the whole picture, what's happening here is so much more than just a simple yes or no test. It's a really powerful piece of science that you can literally hold in the palm of your hand.
Anyone who's ever had to take one of these knows that those 2 or 3 minutes of waiting can feel like an absolute eternity. But in that tiny window of time, what you're actually doing is conducting a really sophisticated, controlled scientific experiment.
No, really, think about it. You start by asking a question. Am I pregnant? Then you perform a controlled experiment using the test. You analyze the results by looking for the lines, and based on that, you either confirm or deny your hypothesis. You are quite literally following the steps of the scientific method.
It really makes you think, doesn't it? From ancient Egyptians planting seeds to modern antibody sandwiches, that fundamental human quest for a clear answer has always pushed innovation forward. And it kind of leaves us with a final thought to chew on. What if we started to see every test we take, every question we ask, as its own tiny personal experiment? Just imagine all the hidden science we could discover all around us, every single day.